So a very good morning to all of you. So, hello, am I audible to all of you?
Yes, sir.
Okay. Let me first wish you a very happy Christmas because before the Christmas, today is the last day, and your classes will be there after 25th. That means from 26th onwards, your classes will be at the normal rhythm. Okay. So we'll be starting from the last day, whatever we have ended, like the different timer and counter modes that are available in 8051 microcontroller. Okay, so by this, uh, we have seen that there are four modes available in the 8051 microcontroller. Okay, so in this case, we have already discussed about the 13-bit timer mode and 16-bit timer mode. Okay, this 13-bit timer mode is the mode 0, and 16-bit timer mode is the mode 1. Okay, so if we move forward, then we'll see that this program is already been discussed. Okay, and now we'll be doing this is the very important thing, that whenever we are using some register, 8-bit register, to generate the time delay, then we have seen some calculations. Okay, and here we will see another calculation. Just write in your copy, otherwise you'll forget. Without writing, this formula cannot be remembered. This formula. Okay, so the time delay is nothing but 256 minus why this kind of things are written. I'll tell you. Okay. So first write down this formula into your copy. Just write down. Done. All of you have written in your copy this formula.
Yes, sir.
Okay. Now let me explain you why this formula is there. So first take, you know that there are two registers, two 8-bit registers together forms the 16-bit register of the timer. Okay, there is timer high and timer low. Okay, so here we can see that this x is, if you take timer 0, then it will be th0 and this will be tl0, and if you take timer 1, then it will be th1 and this will be tl1. Okay, now firstly, in this mode 1, remember this is the formula for mode 1. Okay, this is the formula for mode 1. Okay, hello. Perhaps due to some network problem, my voice was gone. I was muted. I'm sorry for this. So let us again tell that in the mode 1, just we are going back. In the mode 1, we can see this mode 1 means 16-bit timer or counter mode. Okay, so in this 16-bit mode, the maximum count is FFFFH. Okay, so this FFFFH, that means this is the 256 counts. That means if we draw like this FF will be for TH and this FF will be for TL. Okay, so FF means 256 counts, 0 to 255. Okay, now that is why the max, as the maximum count is 256, so this is written 256. Okay, clear or not?
Clear,
Okay,
sir.
okay, so
Yes, sir.
now if I tell you that from 5 to 10, if you can count up to 10 and if you start counting from 5, so how many counts will be there? Just count and tell me.
So 5.
Is it so?
I think 6.
What others tell? If you can count up to 10 and you will start counting from 5, so how many counts will be there? My question is this. So apart from Aditya and Rajkumar, let other people say.
Sir, 6.
Okay, 6. And any other people?
Sir, 6 counts.
And anyone?
Sir, 6.
Okay, now why 6? Rajkumar, can you tell me why 6? Why not
So
5?
because it includes 5.
Yes, very good. So now if you write 10 minus 5 plus 1, okay, can this be taken?
Yes, sir.
So I mean from 5 you need to count. Okay, so if you count from 5 to 10, then this will be, the count will be 10 minus 5 plus 1. Clear? And this will be this particular THX. THX will be counted 256 times. Okay, that is why 256. Now similarly, if you count from, I mean if you start counting from TLX, so 256 minus TLX, because this timer low is also counts up to 256. I mean 256 counts can be there. Okay, so 256 minus TLX, so together they will form this kind of machine cycles and all. And you know the significance of this particulars, this 12 and FOSC. Okay, now write these problems in your copy. Problem 1, problem 2, and problem 3.
So
Yeah. Tell me.
why we don't add in TLX plus 1?
Because if you count like TLX value is like 250. Okay, suppose 250. Now for 250 to 256, how many counts will be there? 6 counts will be there. Is it?
Yes,
Yes,
sir.
sir.
Okay, so 0 to 255. So 250 to 255, that is 6 counts. Okay, so this will be minus, I mean this will be the difference between the 256 and the content of the TLX. Okay, so if this count is completed, that means 256 is counted, this 256 counter is completed, then what will be there? Now you need to just see that if I am writing a drawing this particular THX and TLX, and suppose this is FEH and this is 0 0. Okay, now this is TH and this is TL. Clear? So after one count, this will be incremented by 1, this TL will be incremented by 1. So this will be FF. Okay, so this will be FF, and after the after again the next increment, this will be 0 0. Right or wrong? FF plus 1, that will be 0 0,
Uh,
and there will be here, this will be 1. Clear or not? So you can see for each 256 counts of TL, this TH will be incremented by 1. Clear or not?
Clear, sir.
Okay. So
Sir,
this,
sir,
yes, tell me.
TL, TL will be incremented 2 times. First when it was FEH, then it
Yes,
would become FFH, and
right,
then one increment becomes 0 0.
right.
But initially TH was only 0 0H,
Mm-hmm.
and it was incremented only once, sir.
Yes. So that is not the case. I am telling like every time, every timer or counter operation, the value will be incremented by 1. That the case I have discussed. Here the increment has been done 2 times. Okay. So that FE plus 1, that is FF, then again plus 1, that is 0 0, and TH will be incremented by 1. Okay. Now you just write these problems in your copy. This problem 1, problem 2, and problem 3.
Done, sir.
Okay. So now just take the problem 1. Okay. Everyone has completed? Okay, so take this problem one, that to create a square wave of 50% duty cycle, timer delay 14 microseconds with crystal frequency 12 megahertz. Okay, so now write in your copy that 50% duty cycle. What do you mean by duty cycle? What do you mean by duty cycle?
So on time by off time.
On time by off time, is it so?
It means
Is it so?
50% duty cycle means for half period of time it gets on, and for half period of time it gets off low.
Okay. So if we take this one, okay, so this is T1 and this is T2. Okay, now tell me what is on time and what is off time, T1 or T2?
Sir, T1 is on time and T2 is off time.
Okay, very good. So what will be the duty cycle? What will be the duty
So
cycle in this case?
1/3, sir.
1/3.
so 1/2.
1/2. Where did you find out 1/2? Okay, let me do another thing. Now tell me that what will be the duty cycle. What will be the duty cycle? Everyone is muted.
So T1 plus T2 by T.
Anyone?
So T1 by T2.
Good. नहीं हो रहा है. Write down in your copy that duty cycle equals to, write down duty cycle equals to what has been written. What is written?
Sir, T1 by T1 plus T off.
Is it clear to all of you?
Yes, sir.
This will be the duty cycle. Okay, so write in your copy that duty cycle equals to this. Okay, this is the on time, this is the off time. So on time divided by on time plus off time, this will be the duty cycle of any square wave function. Okay, square wave waveform actually. So 50% means you're telling right, but the concept was like this. That means if t suppose t1, okay, t1 plus t2, okay, then when it will be 50%, if t1 equals to t2, so this will be like t1 by 2 t1. Okay, this t1 and t1 will be cancelled out and it will be like 50%. Clear or not?
Yes, sir.
Okay. Now, I mean, this is the concept. Okay. So I'm erasing this. So now you know that the THX and TLX value will be same. Clear? Now you need to find out the content of TLX and THX. Can you find out? Now write in your copy, write this formula only, whatever formula you have written. Is delay equals to this one. Have you written? I'm focusing on the problem one only. Okay. Is it done? I'm not getting any response.
Done, sir.
Done. Okay. So you know that the THX and TLX will be equal. Okay. So just put the value of THX and TLX equals to uh, suppose X. Okay. THX equals to, write down, THX equals to TLX equals to X. Okay. So the formula will be, I mean, the equation will be, what will be the equation?
256 minus x plus 1 into 256.
Can you show me the show me your copy after writing it?
Yes, sir.
Yeah, then show. So is it visible, everyone?
Yes, sir.
Now at the in the place of delay, that has been given as 14 microseconds. Okay, just in place of delay you need to write 14 microseconds. Okay, and you need to solve it, solve this particular sum. Okay, and by the time Rajkumar, you have forgot to put a second bracket at the end of this x plus 1. Okay,
Yes, sir.
just put this, otherwise it will make confusion. Okay, you can turn off the video and you can solve this equation. Now tell me, after calculation, what is the answer? Is it completed? Students, is it completed?
Sir, 0.94.
What 0.94?
Value of
And
x.
value of x is 0.94.
Yes, sir.
But गलत है. 0.94 कैसे होगा? 0.94 कैसे होगा हमको बताओ. 0.94 होगा तो तुम्हें इसको हेक्साडेसिमल में कन्वर्ट करना है और x का वैल्यू, ये तो वैल्यू TLX में जाएगा. TLX में तो 0.94 हम लोग डाल नहीं सकते क्योंकि माइक्रो कंट्रोलर को बस समझ में आता है हेक्साडेसिमल नंबर, है ना.
Yes.
ठीक से करो. Tell me the other people, please tell. Is it done? Anyone? Is it done? Anyone? Please response.
सर 2 आ रहा है सर.
Hmm?
2 सर.
2.
Yes.
2 in hexadecimal or in decimal? I cannot understand.
Hexadecimal.
Hexadecimal. Okay, can you show me your copy?
Yes sir. तो सर अब अप्रोक्स आ रहा है सर.
Sir, 65535.94.
Imran, can you show me your copy? I can't see. Yeah, show me your copy. A little bit closer. I mean, please keep it steady because otherwise it will not be able to show. Keep it steady. Don't move too much. Okay, so Monica,
Yes, sir.
have you done it?
No, sir.
Why? Show me your copy. Yeah, okay.
Sir, but answer नहीं आ रहा है.
क्यों नहीं आ रहा है? 256x माइनस ये क्या हो गया? 256 से 1 माइनस करके 256 रह गया.
Sir, 256 minus x plus 1 into 256.
फॉर्मूला तो गलत लिखे हो. अभी भी पीपीटी खुला हुआ है, एक बार चेक करो क्या क्या कहाँ पे गलत है. सेकंड ब्रैकेट है, सेकंड ब्रैकेट तुम दिए ही नहीं.
Okay, sir.
Correct it. At the right side, what is there?
सर ट्राई कर रहे बनाने का वही कर लेते
हाँ, वो x plus 1 के बाद सेकंड ब्रैकेट है. तो ये टोटल जो चीज है 256 minus thx plus 1 that will be multiplied by 256.
Sir,
Tell me.
x is equal to 256.94.
256, is it so? Can you show me your copy?
X is
Yes, sir.
Yeah, Rani, tell me. You can continue.
sir, x is equals to 254.99.
Look, if it is 254, you need not to 250. I mean, you need to take as 254 only, because point after decimal points, it cannot be. I mean, it can be converted, but it is very difficult to convert the decimal after the decimal points into its equivalent hexadecimal number. Okay, so that I am telling that you need not to take this after decimal points. Here.
Yes, sir.
So what will be the hexadecimal one? 254 means?
Sir,
FEH, sir.
Very good. That is FEH. Okay. Okay. So now in the problem 2, you can see that the calculate the actual frequency generated in problem 1. Okay. So calculate the actual frequency generated in problem 1. That means you need to put this 254 value. Okay, that means the hexadecimal number FEH value. That FEH value needs to be converted into its equivalent hexadecimal decimal number. And sorry, I'm telling wrong. That x value is 254 in decimal number. and it can be converted to its hexadecimal number, and the answer will be as FEH. Okay, clear or not? Now you need to put the value of 254 in place of x and calculate the value of the delay. Okay, so it will come like 13 point something or 14 point something, near around 14 microseconds. Understood or not? Understood or not? You can ask 100 times, 1000 times,
सर
but you need to
सर एक
present
बार
your
सॉल्व
homework.
करके सर फर्स्ट क्वेश्चन सॉल्व कर दीजिए सर एक बार कॉपी पे से.
Uh, just a minute, Rajkumar, can you show your copy, because I'm not having my mobile phone with me, so that I cannot turn on
But
the video.
I had wrong answer, sir.
Rajkumar, what have you told? I couldn't listen.
But I have wrong answer, sir. X is equal to 256.
Okay, so can you show your copy?
Yes, sir.
Can everyone
Sir,
see? Can everyone see this? Everyone can see this? Okay. Now, if anyone
Yes sir,
not
yes sir.
yeah. So
Understood sir.
yeah. So Rajkumar, you just put on your points on the second line.
Okay, sir.
Put on the pen.
This line, sir?
Yes, this line. Perfect. So there is written 256 minus x plus 1 whole is multiplied by 256 plus 256 minus x. Okay, and you can ignore this 12 and 12, because as this crystal frequency is equal to the value of the machine cycles, so this will be 1, so no problem. Now coming to the next line. Okay, in the next line you can see that Rajkumar, you have done a mistake here. You need to calculate this 256 minus x plus 1, that will be totally multiplied by 256. Okay, that means 255 sorry, 256x minus, what
minus
will be there?
256.
255 minus x, this will be the, okay, you have okay, no,
सर
okay,
ठीक तो है ना
it's
सर?
right, it's right,
वो
it's right, it's
मल्टीप्लाई
right.
कर दिया. Yes, sir.
Yeah, multiply कर दिया. Okay,
Yes,
then
sir.
256 x plus 1, that is 65536 minus 257x. अच्छा, ये यहाँ पे क्या हुआ, एक बार समझाओ तो. This 1 2 3 4, हाँ, yeah, in this line.
So we add 256 minus 256 and minus x.
तो ये
That was
बीच में दो 256 कहाँ से आया, 2 बार 256 कहाँ से आया?
तो
ये दोनों चीज
तो ये मल्टीप्लाई किया ना इसके साथ इनसाइड, इसलिए.
उसका साइन माइनस होगा ना,
Okay.
वो कट जाएगा, उसका साइन माइनस होगा.
यस ये माइनस में ये कट जाएगा.
हाँ कट जाएगा.
ओके
तो
सर.
कितना आता है? अब देखो कैलकुलेशन ठीक करके.
अब आ जाएगा सब सही.
So have you understood?
Yes,
Yes,
sir.
sir.
So what it is coming? How much? How much it is coming? So is the answer is coming like FEH?
254.94 यानी 254.
Yeah, 254. So 254, convert this to its equivalent hexadecimal form, that will be FEH.
TH.
Okay. Now considering this FEH as the content of THX and TLX, okay, you need to calculate the actual frequency. I mean actual delay. That calculate the actual frequency generated in problem 1. Okay, clear or not? Okay, this will be your homework. Okay, these particular 2 points. Now coming to the mode 2 and mode 3, this mode 2 operation is a very interesting one. You can see in the input side, this is same. Okay, this side is same as the before. Now again you can see when this particular square wave whatever is coming in this particular input of this AND gate, when this will be 1, when this will be 1, this timer on control bit will be 1. So when this will be 1, this timer starts counting from this TL, and some value is loaded to TH. That means suppose we are telling that if the value of FDH is loaded to THX, okay, and this TL value is suppose again FDH, okay, so what will be there? That it will count FD, one count FE, and then one count FF, then third count will be overflowed. Then automatically whenever this count of this TLX is overflown, then this switch will be closed, and so this TH value will be loaded to TL automatically, because after the overflow the content of this TL timer low register is set to 00H. Okay, so ये TL को कैसे पता चलेगा कि ये फिर से 00 से शुरू हो रहा है कि नहीं? क्योंकि अगर 00 से शुरू हो गया तो इसका जो हम लोग ऑब्जेक्टिव है that will be disturbed, so that this FD value should be stored somewhere, that after the overflow automatically FD value will be there. Clear or not? So in that cases this mode 2 auto reload mode that is used. Clear or not?
Sir,
Tell me.
मीन्स जब भी टीएल का वैल्यू 00 होगा ऑटोमेटिकली टीएच से एक और वैल्यू टीएल पे जाएगा.
नहीं देखो, TH0 is loaded by some preset value. It may be FD, it may be AB, it may be 00, it may be FF, whatever. Okay, as per your requirement. Now whenever TL is overflown, okay, the timer overflow flag of TL is 1, then automatically the TH value will be loaded to TL. Clear? This is the thing. Whatever the value of this TH, that will be loaded to TL automatically after the completion of this particular counting or timing activity. Clear or not?
Okay, sir.
Okay. Okay. So just a minute. So I'm ending the class for today, and I'm sharing the attendance for your today's class. Just hold on for a second. So after recording the attendance, you may leave the class.
Okay, sir. Thank you, sir.
Thank you, and wish you a very happy Christmas. Merry Christmas. I don't know whether
Same
you
to
may
you, sir.
enjoy or not. Yeah, thank you. Thank you so much, and enjoy tomorrow. Being in being in the home, or get together with your friends and family. Okay. Wish you a very happy and Merry Christmas. Thank you.
Bye.
Thank you, sir.